So welcome to today's lesson. Today we're going to discuss trigonometric functions. Now there are three main types of functions in trigonometry. By now you must have done functions in algebra, which were the parabola, hyperbola and the likes. Right now we have a sine graph or a sine function, which is the general formula is y is equals to sine b into x plus p and then plus q, and then we have the cosine graph, and the general formula of a cosine graph is y is equals to a cos b into x plus p and then plus q, and then you have the tangent graph, which is y is equals to a tan b x plus p and then plus q. So these are the functions that we have, and we have to understand that we somehow did some of them in grade 10, but we shall revisit those we did in grade 10 and then look at the ones that we have now in grade 11, right? So however, it's sine, cosine, and then it's tangent. Now in terms of functions, what you need to know is to sketch the functions now, and then after you are done, or rather when you now know how to sketch, you will then interpret. You will be expected to interpret the functions. So this is to investigate factors such as what does a do to the graph, b, p and q. But today we're just gonna look at sketching the graphs. So you might need to have at least a book, a pencil, that can follow along as we sketch these graphs. Now let's start with the basic graph. Let's start with the sine graph, sine function. The mother graph of all sine functions is this one. The mother graph, or the most basic graph, is y is equals to sine x. So you can use x, you can use theta, it just depends on the question. So how can we sketch this graph? Well, I mostly prefer to do this using a calculator rather than using a table. I mostly prefer to do it with a calculator, but yeah, you're more than welcome to choose which one you want to do. So we're gonna start with the table method. And then this side we're gonna use a calculator. Alright, how do we use the table method? So the first thing we want to do here is that we're gonna draw a table. So instead of using a table, I usually use something that is like this. This is my own table, So what you will have here, you got x, and then after that you're gonna have y. Now in terms of x, please understand that in trigonometry we are dealing with angles, right? So therefore our values of x are not going to be like 1 2 3 4 5 just like we're dealing with in algebra, but rather it's going to be we're gonna use degrees. Okay, so let's draw this. So usually you are given the domain. Let's say that you're given that x is an element from 0 degrees to 360 degrees. So this is the domain. The domain is usually always given so that you know where your graph starts and then where it ends. So when you draw this, you can draw it like this, and then you shall have here, this is your y-axis, and then here it's going to be your x-axis. So here you're gonna have 0, yeah? Then here you are gonna have 1, and then here you're gonna have -1. Then you're gonna have 90 degrees, 180 degrees, 270 degrees, 360 degrees. Now one might ask that how did I know that I have to count in 90s? Why didn't I count in 45s? Maybe 0, 45, 90, 135. Or why didn't I count using 20s? Why didn't I say 0, 20, 40, 60, 80? Well, the reason is because for you to find what you must count with, so your count value or your interval, you can call it your count value or your interval. How you find it is this. You say the period of the graph divided by 4. You say the period divided by 4. Now what is the period of this graph? Well, the period of this graph is actually 360. So please know that in terms of the period, for sine and cos, the period is 360 degrees, and then for tan, the period is 180 degrees. So for sine and cos, the period is 360, but for tan, the period is 180 degrees. So what I did here is that I said 360 degrees divided by 4. It gives me 90. That means when I draw my x-axis, I'm going to count saying 0, 90, 180, 270, 360. So are all the graphs, are we going to count in this way for all of the graphs that we're going to meet in trigonometry? No. The thing is that the period can change, and then we shall talk later about when does the period change. For now, please remember that the period for a sine and a cos graph is 360, and then the period for a tan graph is 180. So now, since we have 0, 90, 180, so you write it here, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Then you're gonna want to have a calculator. Grab your calculator, and then in your calculator you are going to put, for 0 degrees here, you're gonna put sine 0 degrees in your calculator. What do you get? Because x is 0, I substitute 0 degrees where I see x. So what do we get? We get 0. Great. The y values, you don't put degrees for the y values. The degrees are only on x. And then here, please put sine 90 degrees and tell me what you get. Great. Get 1. And then put sine 180 degrees. What do we get? Zero. Nice. What about 270? What do we get when you put sine 270? You get -1. And then lastly, when you put 360 inside there, what do you get? We get 0. Perfect. So now we are in a position to sketch our graph. These are our coordinates: 0 degrees and 0, 90 degrees and 1, 180 degrees and 0, 270 degrees and -1, 360 degrees and 0. And as you can see that the x values have degrees, the y values don't have degrees. So let's start with 0 and 0. I believe it shall be this point. Then let's go to 90 degrees and 1. On x, we're going to locate 90 degrees. Here we have 90 degrees. And then we're going to locate 1. Here is 1. So you're simply going to say on x is 90, right? It's like you do this. You say you go here, right? I usually do it like this. If it's 90 degrees, I go here on 90. The 1 means I must move 1 unit up. So then the point becomes here. I hope you saw that. I say if it's 0 degrees, I go here, and then the 0 on y tells me I must stay there, so the point is here. Whereas for this one, x is 90, and then since y is 1, it means it must shift 1 unit up. So this is 90. Oh, by the way, this is 0 degrees and 0. This is 90 degrees and 1. Now let's go to the next one. The next one is 80 and 0. So I go and check where is 180 degrees. Here is 180 degrees. And then the 0 there means I must not move up or down. I must stay there. So the point is here. 180 degrees and 0. Then the next one is 270 and -1. I go to 270, but the -1 means I must move 1 unit where? Up or down? Down, right? -1 means 1 unit down. So the point is here. So this is 270 degrees and -1. And then the last point is 360 and 0. So that means it is this point here. So we're going to have 360 and 0. Then once we have that, yeah. Great. So now we can, what you do here is that after you're done doing this, you're gonna join the points, but you're gonna join them not using a ruler but freehand. But for you to make a nice sketch, this is what I usually do. I draw a small half here like this, and then the last half like this. Nice. Then it becomes a smooth curve, right? A smooth sine graph. So this is called your sine graph. And we have sketched it using our table method. Now, probably this is the safest method actually of sketching this. If you don't want to, confuse yourself, this is probably the safest method. So to do justice to it, I'm just gonna quickly repeat what I said. But this is the mother graph. All other graphs, they come from this one. They come from this one. So now, just to remember what we did. The first thing is that we drew our Cartesian plane, which was the x and the y axis. Right? We drew our Cartesian plane. We knew we are starting at 0, but we didn't know the interval on x. For y, we know that it is 1. You can even put a 2 there if you want. But as you can see, that the maximum value is 1. The maximum value is 1. So yeah, that's fine. But you can put other values again, like 1, 2, 3 on your y-axis. Then in terms of the x-axis now, we need to find what we call an interval, or what we call a count value, meaning that when I'm counting, I should be counting in what? In 2s, in 3s, in 4s. Should I say 0 degrees, 3 degrees, 6 degrees, 9 degrees? Or should I say 0 degrees, 10 degrees, 20 degrees, 30 degrees? The only way to find that out is to go to the period of the graph. So you first of all recognize the type of function you are dealing with. You are dealing with sine. So therefore, the period of sine is 360. You divide it by 4, you get the count value, which is 90. So then you shall have your 90, 180, 270, and 360. As soon as you have this, you then write them of the t table, okay, on the left side. Then you start substituting those values in the equation for x, substituting them with x. Then you are able to get the y values. And then once you have your y values, that means you have the coordinates. And then once you have the coordinates, it's just a matter of plotting them here. And then you are great, you are fine. Is it understood? Is it clear? Okay, perfect. So yeah, allow me not to do the calculator one. I just feel like it might be a bit unnecessary for now if you have not mastered the table method. Right, let's go to the next one. The next one is the cosine graph. So we're gonna sketch the mother graph of cosine of all cosine graphs, which is y is equals to cos x. So similarly, just like we did the last time, we got a Cartesian plane here. Then you check domain. This time, oh yeah, let's still say from 0. Oh no, its domain is x, ne? So let me just use x there. X an element from 0 to 360 degrees. Right. So still here we can put 1. We can even have a 2, it's fine. But this is our y-axis. And then here it is 0. And then here we shall have a -1. And perhaps a -2 there. Then here it's going to be x. This is going to be y. Now, I actually want it to be very nice. Now I'm going to use a ruler. So let me see my ruler here. Right. If I can say nine, 12, 1, 2, 3, 4. Yeah, not bad. So I've marked my Cartesian plane so that it's nice on scale. So now, how do we count here? Do I have to count using 0, 10, 20, 30 or 0, 1, 2, 3, 4 degrees? Well, you just have to remember the period of a cosine graph. What did we say was the period for cosine graph? We said for cos and sine, the period is 360 degrees, right? So because of that, we're going to say the count value is going to be 360 degrees divided by 4, which gives you 90 degrees. So therefore, when you count there, you're going to say 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Then now you're going to use the table. So in the table, you're going to have x. Then you're going to start with 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. And then this is going to be your y. So to get here, the value of y, you're going to say cos 0 degrees. Here you're going to say cos 90 degrees, cos 180 degrees, cos 270 degrees, cos 360 degrees. So cos 0, I believe it gives you 1. Cos 90 should give you 0. And then this should give you -1. And then this should give you 0. And then I believe this should give you 1. Right? Please tell me if it's like that. Great. Then your coordinates now. Obviously, it's not needed to have this section for coordinates, just for control. 0 and 1, 90 degrees and 0, 180 degrees and minus 1, 270 degrees and 0, and then 360 degrees and 1. So once you have these, those are your coordinates. So now you need to sketch. So how do we sketch? So 0 and 1 means on x I must go to 0, and then the 1 means once I've reached 0, the 1 means I must go up. So the point is here. Okay, so this point here, it's 0 degrees and 1. 0 degrees and 1, and then 90 degrees and 0 is this one. 90 degrees means I must be here, but the 0 means I must stay there. I must not go up or down. So the point here, this is 90 degrees and 0. And then 180 degrees and minus 1 means I must be having 180 on x, and then on y I go 1 unit down. So here's the point here, 180 degrees and minus 1. And then the 270 and 0 is gonna be there. And then 360 means I must go 360 on x, and then the 1 means I must move 1 unit up. So the point is gonna be here. So then I simply join. Don't join like this, ne? Don't join like this. You join nicely like this. Okay, then you go, you make like a cup, and then you draw nicely. It must be curving. Then you draw a nice beautiful cosine graph. And mine is not really accurate because now the point actually was supposed to be somewhere around here. Yeah, it's supposed to be at least here. 360 degrees and 1. Beautiful. So this is the graph cos. That's the mother graph. Right, that is the mother graph there. So that is how we sketch these graphs, right? Quite nice. Yeah, this is the mother graph. So we now have to understand that since these are the graphs, we can have different graphs. Okay, so we can have things like let me give them names. So the first one, I'm gonna call it f of x.
Right. So the minus tells us that the graph has been reflected across the x-axis.
So the minus there, it tells you that there is a reflection across or about the x-axis. Which tells you that if the graph was like this, when it's reflected, now it's going to be like this. This is now going to go down, so it's going to be seen like this. That is reflection. So it's like they flip it across this line. See, so they just flip it. So that is what the negative, that's what the negative does. So let's see if that is really the case, right? We can say, let's have our table here. Then we're gonna have x and y. Then remember, we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now if you say negative cos 0 degrees, what do you get? You get -1.
You get 0.
And then